right. So now we are in. Let's start. Let's begin from where we stopped. Now, like I was saying before we left, what we'll be doing now is finding the specific z-value when you are given the probability or area. So we'll be doing the opposite. You can see my screen, I believe. So it says find the z-value such that the area under the standard normal distribution curve is between 0 and the z-value. Okay, we say find the z-value so that the area under the normal distribution curve between 0 and the z-value is 0.2123. So now, they didn't tell us what direction to go. Whether is it on the left or on the right? So you can choose any direction since it didn't tell you the exact direction. So in that case, it can be on the left side or on the right side. So okay, so now let's see. Remember, they are symmetric. The same thing you have on the left side, you have on the right side. So, but if they give you the direction, then you can decide whether it will be negative or positive. So so what we're gonna do is look for this number in the table and locate our z. We go to our table of normal distribution. Also, I forgot to write down the number that we're looking for. Let me write it down. Is 0.2123. 0.2123. So we can now go and get it from there. Okay. So in that case, we look inside the table, 0.2123. See, you look inside the opposites. So I found it here. Now, when you follow it to the left side, you find it 0.5 as the z, and up, follow it up, 6. So the answer becomes 0.5, 0.56. Write it down, 0.56. It can also be negative 0.56, but the question did not tell us the direction to go. So that's why you can just put answers to be correct. So it can be based on this diagram here, it can be 0.5 is 0.56. If the diagram is on the left side, then it's gonna be negative 0.56. But again, the question didn't tell us the direction to go. So this is the z-value right there. Z-value always have you always stop on the 100th value or 2 decimal places. Any question? It's easy, right?
Excuse me, Professor, I just came in now. Please, can you repeat what you've said?
Yeah, they give you the probability and they ask you to find the z-value. So in that case, you do the opposite. The probability probability they give you is 0.2123. So when you go to the table, you do the opposite of what you did before. I don't know if can you see the table? Can you see the table?
Yes, yes.
So you look for it inside the table this time, and we'll find it here, 0.2123. Follow it to the left, 0.5.
Okay.
And up. Now, if you don't find the exact number,
where can we find this what's it called, the table? Because the ones I printed is not the same with this one you have.
If you printed the one I asked you to print on the canvas, it will be the same because I uploaded I put it there myself. So yes, I put it there as statistical tables. So yeah, you go to files and then you'll find it there. Okay. Now, next question is something similar. Now, if this one, it says find the z value to the right. See, this time, this one, they give us the direction. So to the right of the mean, such that the area under the normal curve is 0.43460 to the right. Say to the right. So that means we know that it will be positive answer. So we have solution. So we have the z value. Z value equals, they give us this number 0.3460, which is on the right, say to the right, so it will be a positive answer. You look for this on the table. On the table, we get, oh, excuse me, let me write it down. I forgot to write it down. 0.3460. 0.3460 have 0.3460. Now 0.3460. We could not find it exactly, but we find, if you don't find the exact number, you use the number that is closest to it. This one number,
there's 3.3461.
Yeah, that's the closest to it. Follow the left, it's 1.0. When you follow the right, 1.0, and go up to, you give us 1.02. And that's the z value right there, 1.02. So the answer becomes 1.02. Okay, 1.02. That's it. Under example, then we'll start looking at applications of normal distribution, standard normal distribution. Now you see, find the z value to the left. See this one again, they give us the direction to the left. That means the answer will be negative. Such that the area under the normal distribution is 0.2245 left. So the answer will be negative. So z equals negative, 0.2245, but because it's set to the left, so the answer will be negative. Let me write this down, 0.2245. So equals, good for this, 0.2245, okay, 0.2245. We put it in the table, 22. I got 2190. See, I got two numbers. I don't know which one is closest. 2245. Let's see. I have two numbers. Two numbers are this one, but this one is too far away. This one is 2257. 221. So we have to, let me write them down. 2224. 2224 and because I have 2245, then 2257, 2257. Let's see which of them is closest. So 2224 and 2257. And the answer was 2245. So let's see which of them is closer. Let's try the first one, which is 2224. So we have our number is 2245. So I got 2245. Just ignore the decimal point. Just 2245 minus the first number, which is 2224, is 21 points away from 2245. Then let's try the second number. Second number is 2257. 2257 minus our number, which is 2245, is 12 points away. So that's this one. I mean, this one is closer. 2257 is closer to 2245. So we're gonna use that. 2257 So 2257, I have 22, what is it? 2 right here. 0. If you follow it to the left, 0.6. If you follow it up, 0. The answer becomes 0.60. Write it down. That's negative 0.60. So go there and put right there. Okay. 0.60. So that's basically what it is. And when they give you the answer, the question in form of a percent, like here it says, find the z value to the left.
Excuse me, Professor, can I see the first one?
This one here?
Yes. Thank you.
Now let's look at this one. Sometimes they give you the in form of percent. In that case, you can just and the number they give us is bigger. Solution. They find the z value to the left. Find the z value to the left. So that means the answer will be negative. So z equals 88, such that 98.87% of the area under the normal curve lies to the right of it. Yeah. Now, but you're looking for the z value to the left. So that means it's 98.87%. When you change the decimal, you have 0.9887. Okay. Now, we're looking for this number on the table. You will see it on the table, on our table. I mean, the other type of table you can see there because that one is cumulative. You're not going to see the maximum you can see here is 0.4999. So now, remembering that we are doing the opposite, and this probably lie on the tail or the data set. What is my so what you're gonna do, because they are symmetric on both sides. One side is 0.5, the other side is 0.5. So subtract. We are doing the opposite anyway. 0.5000. So you can double check this with your calculator. This will give us 0.48. 87. Why are we subtracting? Because remember, this is 0.9887. Now you have two sides. One side is 0.5, the other side is 0.5, making it 1. So our table covers only 1.5 side. So when it is a big number like this, that means that it is that 0.5 is already added to it. And since we're doing the opposite, you just subtract it. So we have 0.9887 minus 0.5, it gives us 0.4887. Now we can go to the table. I need to write it down. I'll write it down. 0.4887. 887. Now you go to the table. You can see it right there. 0.4887. So we have 0.488 right here. You can see right there. Follow it to the left. 2.2. So 2.2. So when you follow it all the way to the left, 2.2, then you go up 8, 2.28. So the answer becomes 2.28. Now you say there, which is 2.28. But remember, it says find the z value to the left, so it's going to be a negative number, minus 2.28. Yeah. Now, we can now look at the standard normal distribution. Look at standard normal distribution. Okay. The standard normal distribution is a normal distribution with a mean of 0 and a standard deviation of 1. So now, that's why if you notice all our diagrams, they are standards. You can see that the mean is 0. All of them, the mean is 0. That's why it's called standard normal distribution. All of the mean is 0. So that means if you're answering the question involving standard deviation, normal distribution, you have to transform it to the standard normal distribution before you can answer the same question. So in this case, you are doing the same thing, but you transform it to the to the standard normal variable before you can now apply it. So how do you transform it? You use this formula here. X minus mean divided by standard deviation, where X is the data value, Z is the standard score, mean is the mean, and the delta is the standard deviation. Let's do one example so you can see how it works. It says under the application of normal distribution, I'll make it big. It said that the mean utility bills of a city is normally distributed. Okay. The mean utility bill for a city is normally distributed with a mean of 100 and a standard deviation of 12. A utility bill is randomly selected. Find the probability that the bill is less than $70. Find the probability that the bill is between $90 and $120. Then find the probability that the bill is more than 140. So we are going to solve only one example here. You can practice the rest at home, as you know. Now, how do we do that? You first of all, you're going to make some transformation for each of these questions. You have to transform 70 to Z. Let's try the first one. Yeah. What is it? Solution. Now, in this case, I think I'm going to push it down so we can have enough room. Another application. So let's see what we have from here. So part A. Well, let's get the values first. Part A, it says the mean is 100. So put mean is 100, and then standard deviation. Yeah. So the mean is 100. Standard deviation is $12. Now for part A, said find the probability that the utility bill is less than $70. So that means our X is $70. So transforming this, you have to transform the $70 to a Z value. That means you have to transform this X to a Z value using this formula here. So that means you have equal X, which is 70, minus, I'm gonna make this big. Let me say 70, 16, okay, 70 minus mean of 100. Divided by standard deviation of 12. So I'm gonna make it big. I don't know why one side is big, the other side is not. Make it both of them big, 16. So let's get this from the calculator. Writing it down, 70 minus 100 over 12. So we go to calculator, 70. Okay, 70.
Minus 2.5.
Okay, you got the answer already? Very good.
Yes.
About 12.
2.5.
Yeah, negative 2.5. Yeah, correct. Negative 2.5. That's 2.50. Okay. Yeah. So we go back and then put it in as negative 2.5. So as you can see now, it is no longer a Z. It is, sorry, it is no longer an X. It is now a Z. See, it is no longer X. It's now a Z. It has been transformed from X to Z. Now it is no longer 70. It is now negative 2.5. So the probability that the bill will be greater than $70 is the same as the probability that that Z, yeah, say greater than. So you gotta put the greater than symbol. Can you see my? You can see my screen, right? Hello?
Yes. Yes.
Okay. Negative 2.50. I mean, this is like saying negative 2.50. Remember, it is 2 digits. It's always 2 digits. Okay, is just like we did the other one. First of all, you have to make the table of, I mean, sorry, the chart. So you draw your charts. Okay. Negative means that it is on the left side. So you have to put it on the left side. So it's a greater than negative 2.5. I'll have it here. I have negative 2.5. 2.5. 50, sorry, mistake. Then the center number is 0. So you can now put your x-axis. Okay, gotta go from here and put your center line, which represents the mean. It says greater than negative 2.5. Look at negative 2.5 right here. It is right here. And it's a greater than that. That means from here, from this spot up. You can't go beyond this. So from here up is bigger than 2.5. So that's why you shed. And then you can get your answer right away. As you can see, it's not that bad. Just a matter of knowing where to shed. And knowing where to, to put your z value. If it's negative, it's on the left side. If it's positive, it's on the right side. That's what it is. That's what it is. Nothing else. All right. Okay. For this.
Excuse me, Professor. Can you please explain the shedding? You said when it's less than, you shed on the left side.
If you say less than, you shed from that z value to the left side when it's less than. Yes. This one is greater than. So you shed from that number to the right. Yeah. All right. And
is it possible to get a video of this, a recording of this class to be uploaded?
All the class I have, the recordings are there. Yeah, sure. I'll put this like I did last week. Now, you can see right here. So
can we get it today?
Yes, you can.
What about a copy of this paper that you're using? What about this paper? Can we get a copy of that also?
I can upload it if you want. I can upload it if you want. Yeah, sure.
Yeah,
Great.
please, because I noticed that sometimes you would have deleted the workings by the time you're uploading.
Let me save it now so I can upload it.
Please, thank you.
Welcome. So now with this, now you can see, remember half of this is 0.5, the whole of half. But here we have 0.5 already because the whole of from this half is 0.5 shaded. So you put 0.5 first because it's already shaded. Now the other half, only this part is shaded. This part are not shaded. So this is the part you look on the table for negative 2.50. Now, because this is symmetric, negative is just to tell you that's on the left side. When you go to the table, look for the 2.5. So let's go to the table and look for 2.5. 2.5. So 2.5 under 0. 2.5 under 0 is 0.4938. 0.4938. So you have 0.4938, which gives us, if you add it, 0.9938. Or if you like, 99.38%. See? So you transform it and you do the same thing with it all the time throughout the day. So now, any question on this one? Excellent. Now let's look at part B. Part B says,
Sorry, can you just I don't know, I didn't really get what you just did now. You just explain.
I have to ask ask a question that specific question. What do you want to know?
Like I can see you calculated the mean standard deviation, all of that. I didn't
No,
really.
it is given. They are given.
Okay.
What I did, I plug them in the formula here to get the Z value.
Okay.
So then look for you understand the rest of it?
So, Professor, I have a question. I'm sorry, were you finished asking your question?
Yeah.
Yeah, I just want him to scroll to the question so I can take the picture. Yeah, thank you.
So, am I understanding? Can you go back up so we can see the drawing?
Go more up.
Down so you can see the
down.
drawing. So, when you get to 2.5, you're getting the 0.5 because of the half, right?
Yeah, this half, yes.
Okay.
Half, yes.
Okay. All right, I got it. That's all I wanted to know.
Okay.
Please, I'm not taking the question, please. Let me just.
Please take a photo of it so that that'll be faster. Remember, this thing time us out at
Thank you. Yeah.
You're welcome. You're welcome. Now the second part says find the probability that the utility bill is between $90 and $120. In this case, we have to transform two numbers. We have to transform $90 and transfer $120, and then go all the way the same steps with it. So let's do it. Between 90 and 120. 90 and 120. Yeah. So let's do it. Part B. Again, remember the mean is still the same. The mean is 100. Standard deviation is 12. So let me copy from there and then change only the X. The only thing that changes is the X. So mean, part B, the mean is 100. Standard deviation is 2. There are two numbers to transform now this time. One is the X1, which is 90. 90. And X2 is second number because it's between 90 and $120. 120. So we have two numbers, two values, two X values that we are working on. One is X1 and the other one is X2. So we're going to transform both of them. And then remember the formula for transformation is still the same formula. What is it? What is it? What is it? What is it? Right here. Okay. Z. So in this case, we have two of them. So we're going to have two. The first one will be X1 minus mean by standard deviation. We're going to have equals for X1 is 90 minus mean of 100. Okay, divided by standard deviation of 12 equal. So I'm going to make it look big. Yeah. So we did it for the first one. First one have 90. So I'm going to write it down. 90 minus 100 over 12. So 90 minus 100.
Minus 0.3833.
You did it already. Very, very good. Let me just show it straight to everyone. Yeah, very, very good. 90. Okay, minus 100. Okay, divided by 12. Minus 0.833. That means now remember Z value is at two decimal places. So you're gonna be negative 0.83. Negative 0.83. So I'm gonna go and put it in. Negative 0.83. It is 0.83. I will repeat it because there are two numbers, two X values to transform. We repeat the same process for X2. In that case, we have our X2, let me say our Z2. That is Z2. I have to put Z1 here and Z2 for each. So this one is our Z1. As a matter of fact, let me write it down. I have 10 minutes left. So I have Z1 equals negative 0.883 as our Z1. So let's repeat the same process. Equals, we got 120 plus 100 divided by 12 So we follow the same process. Let me make it a little bigger. Excuse me, make it bigger. Okay, make it 16. That gives us Z2 equals, now let's go to the calculator and calculate it.
1.67.
Very good. So it's 120, right? 120. 1.666, I mean it's 1.67, correct? 1.67. 1.67. I'm gonna make it Z2. Now, it is no longer X1. It is now Z1. And it's no longer 90, it is now negative 0.83. It is no longer X2, it is now Z2. And it is no longer 120 have been transformed to 1.67. So that the probability that the bill is between $90 and 120 becomes the probability of that term of negative 0.83. Oh, I didn't put this 0.83 less than Z. Start the formula. Okay, less than Z, less than 1.67. Now between the two of them, 1.67. Okay, that give us make our chart first. We draw this chart. Okay, from here. Okay. Oops, I screwed up. I screwed up. Let me draw it again. Okay, got it. All right. Yeah. Right. So I'm gonna put the numbers. I got negative 0.83, negative 0.83. But I put too close. Okay. Now have it 0 center and 1.67, 1.67. Now between them, so I can now put the x-axis. I put the x-axis. I put the center line. See, between these two values, one of them is 0.83. I'm gonna move it a little bit closer. 0.83. Okay. And this one is here. Now, and the other next value is 1.67. So you gotta shed the two. Shed. Okay. Between these two numbers. So you look on the table for the two numbers. Okay, here's. All right. Okay. So you can see that it's basically the same thing we have been doing before. Except that this one you have to transform them first to normal variable to get the Z values. And then you solve the equation, see? Between these two numbers. So now it becomes, let's find the find 0.83, to find negative 0.83 and also 1.67. Find their area from the table, then add them. So negative 0.83, we'll find it here. 0.8 under 3. 0, 1, 2, 3. See right there. Give us point. Say 0.29 because this is 0.8 under 3. 0.2967. 67. The other number is 1.67, I believe. is 1.67. Okay, let's look for 1.67. 1.6 under 7. The 1.6 is right here. So you go under 7. See, it's under 7, right? See 7 right there. So 1.6. 1.67. Okay. 0.4525. 0.4525. So let's go and put them in. Our time is almost up. So let's give us 0.2967 plus 0.4525. That'll give us the required probability we're looking for. So we got 0.2967 plus 0.4525. That'll give us 0.74, 0.7492. So our answer becomes, the required probability becomes 0.7492. 0.7492. Or if you like, you can call it 74.92%. So that's what it is. So there's nothing to eat. Any question before we go to we are timed out? So the timeline is just read the question, then follow the direction from here to transform, and then if you say to the right, draw the chart, put it on the right. So I leave the part C for you to try as a practice at home. We'll come back. We'll begin from this section. We'll be finding data values given specific probabilities, and then we'll round up by doing the central limit theorem. And that will be hopefully we'll finish it today. Now, so when we come back, we start from here. Okay. And we have 1 minute left, so I'm gonna time it out.
Can I see the question for the last, the one you asked us to practice?
Oh, so that is right here. There are 2 of them actually. Right, this one, the last one, part C. It's the same question, but part C of it. Take a photo of it. And then the second one is this one. Here. You can take a photo of it as well. Use the practice. So we'll come back to start from here. So let me time us out so we can begin on time. See you in 10 minutes.